Let's try to understand what cancer is all about. Imagine your body as a bustling, vibrant city, constantly active and full of life. This incredible city is built from trillions of tiny building blocks, each one meticulously crafted and working in harmony. We call these building blocks cells. Normally, these cells grow, divide, and multiply in a controlled manner, ensuring the city's infrastructure remains strong and functional. They work together, each with a specific job, and eventually, they die in a highly organized way, a natural part of the city's life cycle. Think of it like traffic lights keeping everything moving smoothly, preventing gridlock and ensuring resources are distributed efficiently. But what if those traffic lights break down, causing malfunctions and disruptions throughout the city? Suddenly, chaos erupts. The smooth flow of traffic grinds to a halt, and the city's systems become overwhelmed. Cancer is like that chaos, a breakdown in the normal order of things within our body's city. Specifically, it's what happens when some cells start growing out of control, dividing rapidly and without any regulation. These rogue cells begin ignoring the usual rules that govern cell growth and behavior, acting independently and disrupting the delicate balance of the body. These abnormal cells can invade nearby tissues, disrupting their normal function and causing damage. And, even more concerning, they can even travel to other parts of the body through the bloodstream or lymphatic system. It's important to remember that this isn't an outside invader attacking the body. Instead, it starts with our own cells malfunctioning, undergoing genetic changes that cause them to behave abnormally. These out-of-control cells can accumulate and form lumps, which we call tumors. Now, it's crucial to understand that not all tumors are cancerous. There are different types of tumors. Benign tumors are generally harmless because they don't spread to other parts of the body. They remain localized. But malignant ones do pose a threat. Malignant tumors have the ability to break away from the original site and travel through the body via the bloodstream or lymphatic system and start new tumors elsewhere in the body, a process that can be incredibly dangerous. This process is called metastasis, and it's a key characteristic of cancer. That's what makes cancer so dangerous, its ability to spread and establish itself in different locations throughout the body. It spreads, making treatment more complex. And remember, cancer isn't just one single disease, it's actually a group of over 100 different diseases, each with its own unique characteristics and behaviors. Each type of cancer starts in different cells or organs of the body, affecting various tissues and systems. But what they all share is the fundamental characteristic of unchecked cell growth, the loss of normal control over cell division. Understanding this basic idea, that cancer is essentially uncontrolled cell growth, is the first step to demystifying cancer and empowering ourselves with knowledge. When we see cancer as a biological process, a disruption of normal cellular mechanisms, we can begin to study it more effectively, understand its complexities, and ultimately, develop more effective strategies to fight it. Every cell in your body, from the tip of your toes to the top of your head, is a marvel of biological engineering. They work tirelessly, performing countless functions to keep you alive and well. Each one has a DNA instruction manual, a complex and intricate code that dictates its every move. This manual is the blueprint for life, containing all the information needed for the cell to function correctly. This DNA is constantly at work, telling each cell how to grow, when to divide, and what specific role it should play in the grand scheme of your body's ecosystem. It's a carefully orchestrated process, essential for maintaining health and balance. When cells copy themselves, a process vital for growth and repair, they meticulously copy this DNA, ensuring that the new cells receive the same set of instructions. This replication process is usually incredibly accurate, but sometimes, despite the body's best efforts, mistakes happen. These errors can occur during the copying process or be caused by external factors. These mistakes or mutations are alterations to the DNA sequence. They represent a deviation from the original perfect blueprint. Think of them as typos in the manual, small errors that can sometimes slip through unnoticed. Most of the time, these typos are harmless. Most typos don't matter. They might change a word slightly, but the overall meaning remains the same. The cell can still function normally, and the error is inconsequential. But some hit critical genes, the ones that act as master controllers, regulating cell growth, division, and even cell death. These genes are essential for maintaining order and preventing chaos. Imagine a car where the accelerator gets stuck, constantly pushing the engine to go faster, or the brakes fail, leaving you unable to stop. In a similar way, if these critical genes are mutated, a cell can start dividing uncontrollably, ignoring the signals that normally keep it in check. This is how a tumor begins, a tiny seed of uncontrolled growth, planted by a genetic mishap. It starts as a small cluster of abnormal cells, cells that have lost their way and are no longer following the rules of the body. Over time, these cells can pick up more mutations, further disrupting their internal programming and making them even more different from their healthy neighbors. These accumulating mutations can make them even more aggressive, allowing them to grow faster and spread more easily. Some learn to create their own blood supply, a clever but dangerous adaptation that fuels their rapid growth. This process, called angiogenesis, involves the formation of new blood vessels that specifically feed the tumor, providing it with the nutrients and oxygen it needs to thrive. With this dedicated blood supply, they can grow bigger, expanding their reach and disrupting the surrounding tissues. Eventually, a few may break away from the main tumor mass, seeking new territory to conquer. They enter the bloodstream, using it as a highway to travel to distant locations within the body, and travel to new parts of the body, searching for a suitable environment to establish new colonies. This is metastasis, the spread of cancer from its original site to other organs and tissues. This is often the most dangerous stage, as it makes the disease much harder to treat and control. Cancer starts small, often with just a single cell gone awry, but with the right mutations and enough time, it can become a serious threat to your health and well-being. It's a story of cells gone rogue, cells that have abandoned their normal roles and turned against the body they were meant to serve. It's a rebellion against the body's carefully maintained order, a disruption of the delicate balance that keeps us healthy. That's how cancer begins, a complex and multifaceted process driven by genetic mutations and cellular misbehavior. At the heart of cancer lies a fundamental question: what triggers these DNA mutations, the very changes that set the stage for uncontrolled cell growth? The answer, unfortunately, isn't simple. It's usually a complex interplay, a mix of various factors accumulating over a lifetime. Think of it as a puzzle with many pieces, each contributing to the overall picture of cancer development. Some individuals inherit faulty genes from their parents, significantly raising their risk of developing certain cancers. These inherited predispositions act as a head start for the disease. But the vast majority of mutations, the ones that ultimately lead to cancer, happen during our lives, influenced by the world around us and the choices we make. Environmental factors play a significant role. Consider tobacco smoke, a notorious culprit packed with carcinogenic chemicals. Then there are UV rays from the sun, an invisible form of radiation that can penetrate our skin and wreak havoc on our DNA. Exposure to certain chemicals, like asbestos, a known carcinogen, can also inflict damage. These external aggressors can directly damage DNA, disrupting its delicate structure and paving the way for cancerous growth. But it's not just about what's outside. Our internal environment matters too. Lifestyle choices have a profound impact. A poor diet, lacking in essential nutrients and rich in processed foods, a lack of regular exercise, depriving our bodies of vital movement and metabolic regulation, and being overweight or obese, creating a state of chronic inflammation within the body, all significantly increase the risk of developing various types of cancer. For example, smoking remains the leading cause of preventable cancer deaths worldwide, a stark reminder of the power of lifestyle choices. Certain infections like the human papillomavirus or HPV, or hepatitis B and C viruses, which primarily affect the liver, can also trigger cancer development through various mechanisms. They might directly damage DNA or create an environment of chronic inflammation, which promotes tumor growth. But here's the good news, the empowering truth. Many of these risk factors are within our control. We have the power to influence our own health destinies. Vaccines, like the HPV vaccine, offer a powerful shield against cancer-causing infections. They can effectively prevent some cancers by targeting the viruses that trigger them. Understanding what raises our individual risk, being aware of the factors that contribute to cancer development, empowers us to make healthier choices, to adopt habits that protect our DNA and reduce our vulnerability. It's important to acknowledge that cancer isn't always preventable. Despite our best efforts, the disease can still arise. But by understanding the risk factors and taking proactive steps, we can significantly lower our odds, tilting the scales in our favor. Knowledge is power, and in the fight against cancer, it's our most valuable weapon. Cancer comes in many forms, usually named for where it starts. Breast cancer is the most common worldwide, mostly in women, but men can get it too. Early detection, like self-exams and mammograms, saves lives. Lung cancer is the deadliest, mostly caused by smoking, but also by air pollution or radon. Prostate cancer is most common in older men. Some types grow slowly, others spread quickly. Colorectal cancer starts as harmless polyps in the colon or rectum, which can turn cancerous over time. Screening tests like colonoscopies can catch and remove polyps early. Diet and lifestyle play a big role in colorectal cancer risk. Prevention and early detection are key. Awareness is a powerful tool in fighting cancer. Watch for unexplained weight loss, persistent fatigue, or fevers without a clear cause. Specific signs matter too: new or changing moles, changes in bowel habits, a persistent cough, or lumps under the skin. Unusual bleeding or discharge, trouble swallowing, or sores that don't heal should never be ignored. Most symptoms aren't cancer, but if something lasts for weeks, see a doctor. Knowing your own body is crucial. Don't panic, just be proactive. Early action saves lives. When cancer is suspected, doctors act like detectives. They start with a physical exam and questions about your health and family history. Blood and urine tests can reveal clues like abnormal cells or tumor markers. Imaging, X-rays, Connecticut scans, MRIs, or PET scans shows where tumors might be hiding, but only a biopsy, where a small tissue sample is examined under a microscope, can confirm cancer. The biopsy tells doctors what type of cancer it is, how aggressive it looks, and how far it's spread. This information shapes the treatment plan. Early and accurate diagnosis is critical. The sooner cancer is found, the better the chances for effective treatment. Once cancer is diagnosed, doctors create a personalized treatment plan. The main tools are surgery, chemotherapy, and radiation, often used together. Surgery removes tumors. Sometimes it's a cure, sometimes it helps other treatments work better. Chemotherapy uses drugs to kill fast-growing cells throughout the body, but can cause side effects. Radiation targets tumors with high-energy beams, sparing healthy tissue as much as possible. Sometimes treatments are used to relieve symptoms, not just to cure. The goal: cure, control, or comfort, depending on the case. Every plan is unique. Cancer treatment is evolving fast, with new hope on the horizon. Immunotherapy helps the immune system recognize and attack cancer cells. Checkpoint inhibitors release the brakes on immune cells, letting them target cancer. Targeted therapies focus on specific genetic mutations in cancer cells, often with fewer side effects. Precision medicine matches the right drug to the right patient. CAR T-cell therapy engineers a patient's own immune cells to hunt down cancer. Liquid biopsies, simple blood tests, may soon detect cancer early by finding tumor DNA. Artificial intelligence is helping doctors read scans and analyze samples faster and more accurately. These advances mean more personalized, effective, and less toxic treatments. The future is bright and full of promise. Science is turning the tide. Understanding cancer turns fear into action. It's not a curse, but a disease we can study, prevent, and treat. Many risk factors, like smoking or sun exposure, are within our control. Healthy choices and vaccines can lower our risk. Knowing the warning signs helps us catch cancer early, when it's most treatable. Awareness empowers us to advocate for ourselves and our loved ones. Open conversations reduce stigma and encourage prevention. Science has made huge progress, and hope is real. By learning and sharing, we build a healthier future. Knowledge is our best defense.